Okay, so now we're gonna move into, we talked about that, the building blocks of life. And we mentioned that, we don't just begin with a population. The population is made up of organisms. Organisms are made up of organ systems. Organ systems are made up of organs. And organs are made up of tissues, what we looked at in the microscope today. And tissues are made up of cells. And are cells are made up of macro and micromolecules, and you have the organelles. And now we're gonna go in depth. Okay, so what are elements? We talked about this last week. So this now is a recap. So this PowerPoint slide, nothing here is new. Everything we did on the whiteboard. So this is now just a review, like an exam review, because we did that in depth last week. So the elements in various combinations form matter, including living things. So, I'm sorry? Yeah, it's a unique form of matter. So a combination. So elements do not exist in isolation. So you have water that is made up of two H's and one O combined together with intramolecular bonds, with these covalent bonds. There are abundant elements. So abundant elements in most organisms are these six: the carbon, the hydrogens, the nitrogen, and the oxygen, the sulfur, and the phosphorus. These are your main six elements that are found in nature. So the biological processes follow and obey the laws of physics and chemistry. That's why we have this hybrid field known as biophysics and biochemistry, the physics of the living systems and the chemistry of the living systems. Okay, the matter occupies space and has mass. So you can never have mass unless you have these elements that together make up the matter. Elements are unique forms of matter with specific properties. So some elements are cations plus charged. Some elements are anions. They are negatively charged. What's the difference between a cation and an anion? What's the difference between a cation and an anion? Excellent. So which one loses the electron and which one gains the electron? So the cation loses the electron. So the cation, it has a letter T. So cation, it is positively charged. Anion, anion, it is negatively charged. So this is very counterintuitive, because if they tell you that your bank account has plus 100,000, now you believe you gained $100,000. But if they tell you your bank account is minus 100,000, now that's painful. Now you lost $100,000. So in the elements, it's the other way around, because the language is not in plus, the language is in minus. So they exchange electrons. The currency, their dollar is the electron. So the sodium would give an electron to the chloride. Now, who gained the electron? The chloride. The chloride has a minus charge, and the sodium lost it. Thank you. The electron, the sodium lost an electron, so it's positively charged. In our world, a plus here means I gained. So if I tell you which of these two is the winner, you would think it's the sodium, but it really isn't. It is the chloride, because it has gained a minus charge. So the currency is in the language of electrons, the language of minus. You give me minus, you make me rich with minuses. You are plus because you lost a minus. So in the elements, it is bad if you are plus, it is good if you are minus. So then there is Ca plus 2. Now what about this guy, Ca plus 2? What happened to him? He lost what? Two electrons, so he is really poor. He lost 2 electrons. The sodium has lost how many electrons? 1. So if you have a minus, you are rich in electrons, minuses. Okay, so that's how the bonds are made, by sharing electrons. So the water, H2O, looks like that. Oxygen with 2 H's, because hydrogen will say, I'll put up 1 electron. Oxygen will say, I'll put up 1 electron too. We have a company here. It's called a bond. It's called a covalent bond. If we are sharing, you put $10,000, I put $10,000, we buy a car, then that makes us in a bond. This is known as a covalent bond. But the bond here, this is like supposedly marital bond, 50,000 from husband, 50,000 from wife, they have a house, they buy the house together. That's one thing. That's the covalent bond. Here, it's sodium gave chloride a minus. That's when you give a gift. When you give the gift, the ring, you give a gift, you lose money to give the ring, and supposedly you get in response appreciation or that kind of stuff. So here, this is not a covalent bond. This is really important. This is really important, the difference between covalent bond and ionic bond. In covalent bond, they are sharing. This one is putting up 50,000, the other one is putting up 50,000, they are sharing a mortgage. But in NaCl, one is giving a ring and the other one is getting the ring. So here, the ring is the electron. So are we sharing the electrons? That makes us covalent. Is one giving the electron and losing the electron? That makes it ionic. Are we clear?
Ionic is when one gives and loses.
Is when one gives an electron and loses it and becomes, talk to me in this language, and becomes a cation, because it lost, it became positive, it's poor. Its bank account withdrew electrons, so it's now positive, it's a cation. While the other one gained a minus charge, so it became a anion. Yeah, that's ionic. That's not sharing. There's no sharing. One lost the ring, the other one got the ring. But in sharing a house, sharing a mortgage, that's an example of covalent bond. Okay. So matter can be liquid, gas, or solid. So common elements in organisms are, so you need to know these six, the six major. The six major are, you can make a mnemonic. Carbon, hydrogen, Cha, CH. Then put an oxygen there, it's a O, CHO. Then put an N, N. So chan.
Nitrogen.
So nitrogen. So C for carbon, H for hydrogen, O for oxygen, N for nitrogen, and P for sulfur, P for phosphorus, and S for sulfur. Chomps. Whatever that helps you remember. So these are the six. These are the six that chomps. So carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Chomps. These are the six major bioavailable elements.
Can you do that again?
Okay. CH, it's right. CHONPS. Carbon, it's on the, you see it's on the slide, right? Carbon, it's on the slide, lecture slide. Carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus.
Elements of living organisms.
These are the abundant. These are the most available. Okay. Now let's look at the atom. The atom is the smallest unit retaining an element's chemical property. So that's gonna bring us into the atomic number. The atomic number is like your phone number. Nobody shares that number. That's why they call it the atomic number. That's your atom number on the periodic table. If I dial 1718, 123, 4, 5, 6, 7, that's one person. If I change one digit, that's a whole different number now. Same thing with the atomic number. You can never change the atomic number and still have the same element. You will have a different atom now because you change the atomic number. So in the atom, we have to see what does the atom look like from the inside. The atom from the inside has the atom has a p proton that is positively charged, and it has an n, a neutron that is negatively charged, and the electrons are spinning on the outside. Now you see why their currency of exchange is the minus electron. The neutrons are neutral, zero. Neutrons are zero. But the electrons are negatively charged. So if they want to exchange, they exchange the electrons. So their currency is the electron. So now you have to know the atomic number. The atomic number is the proton number. So hydrogen has a atomic number 1. So how many protons does it have? 1. Now hydrogen has an atomic number 1. There is deuterium and there is tritium. These are all different variations of hydrogen, but obviously 1, 2, and 3 can never be the atomic number. Then that makes them what? If they can never be the atomic number, that makes them the? If they, you see all of them. Yeah, they are isotopes. They are isotopes. Excellent. But what's an isotope? Obviously, 1, 2, and 3 refers to what? The number of protons. If hydrogen is 1 and deuterium has 2 protons, then they can never be isotopes.
They have different neutrons.
They have, exactly. So they must have the same proton. So hydrogen has 1 proton, deuterium has 1 proton, tritium has 1 proton. But different neutrons. So here, hydrogen has 1 proton, 0 neutron. So its mass number is different. So the mass number is proton plus neutron, while atomic number is just proton. So the hydrogen has a proton number 1 and a mass number 1 plus 0 is 1. So hydrogen has a same atomic and same mass number. The deuterium has an atomic.
You said the mass number has proton plus neutron.
Yes. Yes. So hydrogen happens to have the same atomic as mass number because it has no neutrons. So it has 1 proton and 0 neutrons. 1 plus 0 is 1. So it has an atomic number of 1 and a mass number of 1. This will never happen again. Deuterium has obviously atomic number 1 and it has a mass number 1, and that is going to be 2. That's going to come out to 2. Tritium. Tritium has a atomic number of how much? What's the atomic number for tritium? 1. Because if it changes, it will no longer be an isotope of hydrogen. So it has atomic number of 1. And what's the mass number for tritium? 3. Why is it 3? Because it's tritium. And if it's 3, that means the proton number is 1. What's the neutron number? 2. So 1 plus 2, that's going to come out to 3. So the proton number on itself, that's your atomic number. That's your phone number. If you're 1, that's hydrogen. 2, that's helium. But the neutrons, you add them to the proton, that will give you the mass number. So isotopes have the same atomic number. They just have the different, what number? Mass number, because they have different neutrons. Very good. So if you look in the slide, the atoms consist of a nucleus, protons and neutrons, and orbiting electrons. Protons are positively charged, neutrons are uncharged, and electrons are negatively charged. The atomic number is the number of protons, which distinguishes elements from each other. We talked about that. The atomic number is the number of protons. We talked about this last week. You guys forgot all about this? No, it was on YouTube. I posted it for you to watch at home. Yeah. Okay. Let me show you last week's. Okay, this is not good. Okay, so if you go on YouTube, okay, and if you go to my YouTube channel,
It's the first time hearing that. Me too.
okay, so this last week, right? This was us last week.
No, that was.
This is the scientific, yeah, this is last week. Okay, good morning, guys. Let's begin, please. Last week we talked about the concept and then applying it in technology and finding a real world solution based on the knowledge. My name. Just show my name. So basic versus applied science. Okay, please listen. That's an example of a classification of how we approach the science. But then we say that we study on a daily basis. A serendipity in science. To the excellent. Leads to the hypothesis. And we said the falsifiable. So the hypothesis. But you know something bad happened last week. The microphone died.
Yeah.
So, yeah, remember that. My battery is working. So the difference between the experimental day 3, then you look our experimental design in the lung. Yeah, that's when it went off. So thank God there's half an hour to listen. So do that half an hour. I'm so mad because I explained so much. Okay, so listen to this half hour and then what's left? He's gonna come back, I think, after. Yeah, then he can come back. So whatever you can find, listen to that. It's very important. Was this light up the whole time? Yeah, this one when I discovered it. Yeah, so what can I do? So now that means it wasn't working. And if it's not working, that means my sound. I'm gonna use study guide. So now enjoy. You see with the study guide. You see that's what makes students happy. I'll give you a study guide. Oh, okay. Anyway, so okay, so there's still hope. It died. Okay, I'll give you. Don't worry. Look. You see, that's what I was doing last week. No, you guys, you can't do that. You see, that's what I'm doing right here. We did this last week, and you guys don't remember the proton and the mass number. No. You see, the same thing. What we did last week. And we even did the polar bonds. Oh, no. Okay. Okay, guys. Let's continue. Things happen. It's life. So go online and you will find, and I'm gonna give you your first video summary. It's gonna be online, and you're gonna find my channel there. So just look there, you'll see the recordings there. Okay, so the atomic number, we talked about that. The mass number is the sum of the number of protons and neutrons And isotopes are atoms with the same number of protons, but different number of neutrons. We did that. Deuterium and tritium and hydrogen, they're all different isotopes. We did all of that. We've repeated it.
It's going to a review.
Okay, we're doing a review. So there's no need for the study guide then. We're doing a review. Okay, all right. Okay, that's fine. All right, so let's do that. So now let's look at here. This is the, guys, what is this? This is the periodic table. So now let's look at oxygen. 0888. What is 8? It didn't change. So that means that's the phone number, that's the social security number. It can never change. That's the atomic number. Now who's changing? 16, 17, and 18. That's the mass number, which signifies that who's increasing now? The neutrons. So on the exam, if I give you 08 and 17 and ask you what's the atomic number, you say 8. What's the mass number? 17. What's the neutron? You say, oh, it's not there. So then the neutron is not there. You have to, so what do you do to calculate it? Add it, you subtract 17 minus 8. Same thing here for nitrogen. 777, that's definitely the atomic number. 13, 14, 15, that's the mass number. So isotope, all of these guys are isotopes, have an increasing number of, look at what the arrow is pointing to. The arrow is pointing to increasing number of neutrons, and that's increasing number of protons. Isotopes are two or more forms of the same element that have the same mass, that have different mass numbers. So sometimes isotopes are stable while others are unstable, making them radioactive. So radioactive isotopes emit energy as they eject neutrons, protons, and other particles to become stable. So this radioactive decay transforms one element into another. So carbon dating. So carbon-14 is a radioactive isotope created in the atmosphere and incorporated into the living organisms. So after death, this carbon-14, this radioactive isotope in organisms, decays at a rate that is known to us. So we compare the carbon with mass number 14, carbon-14, to the ratio of carbon-12, then scientists can use the carbon dating to determine the ages of these fossils and the once living materials up to even 50,000 years old. So for older materials, other radiometric dating is used, such as longer lived isotopes like potassium-40 and uranium-235. So that just shows you the importance of the mass number. The periodic table organizes elements by their physical properties and chemical reactivity. So their ability to chemically bond with each other. Elements in the same group have similar electron configuration. If you are on the same group, a group is a column or a period. So if you look at the periodic table, if we say a couple of elements are in the same group, does that mean they are on the same row or they are on the same column?
Same column.
Of course not. I don't even know the periodic table. But you now have to know how to read it. But you don't have to memorize it. Unbelievable. No way. I don't think the chemists memorize it. But you should be able to refer. So when you go back and see these two numbers, now that one you gotta know. You gotta know which number is the atomic, which one is the mass number. No. I'll give you special ones to know. Okay, their ability to chemically bond with each other. So elements in the same group have similar electron configurations. So elements in the same group have similar electron configurations. So molecules form when atoms chemically bond to each other. This is really, really important. When two atoms are sharing, no one gave the other electrons. They are both sharing the electrons. What kind of bond is that? Covalent bond. If one gave an electron to the other atom, what is that? Ionic. And the one who gave the electron, what is it called? Cation. And if one received the electron, anion. Not ion, huh? It's
One that gave is the cation and the one that.
No, the one
No,
that
no, no.
gave is the cation.
that gave up. That lost. The one that's plus. I told you cation, plus.
Ion receives, basically.
Yes.
The plus
Okay. That one is pretty. Cation. I put the letter T as a plus, right? So you become a cation when you gain electron or when you lose electron? When you lose electron. When you lose electron, you became plus. And then the anion, I put the 1 minus upside down. Anion is when you gain electron. So now this is the periodic table. So the letter is the symbol. And the number on the top, because that's the most important one, is always on the top. That is the atomic number. While the atomic weight and mass, one student told me, Professor, this is atomic weight. And you said mass. Same tomato. In fact, in physics, it's a little different because your mass is the same, but your weight on Earth is different than your weight on the moon. So your weight is your mass times gravity. So on Earth, your weight is your mass times gravity, which is 9.8. The gravity of the moon is not 0.8. It is less than that. So then your weight is going to be, your mass is the same. It's just multiplied by gravity. But for all intents and purposes here for life sciences, for biology, mass and weight are pretty the same.
Okay.
So the one on the top, you got to know this is, if you're concerned about the periodic table, you got to know H is the symbol, the atomic number is 1, and the atomic mass is down here in the bottom. The Bohr model represents the electrons that orbit the nucleus in a specific distance from the nucleus. So each orbit forms a shell or an energy level, and shells are filled in a consistent order. So electrons in the outermost shell determine the atom's stability. The outermost shell. This rule here, the octet rule, states that atoms are stable with 8 electrons in the valence shell. So they are stable when they have 8 electrons out in the outermost shell. Okay, so this shows you here in group 1, you have hydrogen, lithium, and sodium. You see that group 1, they have 1 electron. So hydrogen has 1 electron on its outer valence shell, while lithium has, period 2, it has 2 on the, so all of them have on the outermost shell 1 electron. But if you are on period 2, you have 2 pairs. If you are on period 3, you have 3 pairs. So that just shows you The symbol shows you the element, and that the outermost shell is what determines how stable an atom is. So these are electron configurations and reactivity. So elements in the same group on the periodic table have the same number of electrons in their outer shell. So elements in the same group on the periodic table have the same number of electrons in the outer shell. If you are on the same group, you have the same number of electrons on the outer shell. So group 18 atoms all have full outer electron shells, making them very stable and inert. These are known as the noble gases because they are stable. So group 18, they have fulfilled their octet, so they do not participate in any chemical reactivity. Group 1, H, hydrogen, lithium, and sodium, these atoms readily lose or share they have a one outer electron. They have a $1, this one electron. So we talked about how sodium donates an electron to chlorine. Now these orbitals, so scientists now use the electron cloud or the quantum mechanics or the quantum mechanical model instead of the Bohr model. So electrons behave as particles and waves. So their location is within the electron orbital, within the energy level. So each electron orbital represents an energy level. So an electron orbital is a region, is a path that this electron orbits around the nucleus, in which the electron is likely to be at any given time. There are subshells designated as S, P, D, and F, and they can hold varying numbers of orbitals and electrons. So each orbital can hold a maximum of 2 electrons, and electrons will fulfill the orbitals from the lowest to the highest energy levels. So these are the suborbitals that the electrons will fulfill from the lowest energy level to the highest. So we said that groups have one thing in common, and that is how many electrons are orbiting in their farthest valence shell. So as a group, they have each member choose an element from periods 2, 3, or 4 from the periodic table that is not this. So this is a group activity. Forget about that one. Okay. Chemical reactions and molecule. We alluded to that elements are the most stable when their outermost electron shell is filled. So when their outermost electron shell is filled, that's known as the octet rule. So atoms form chemical bonds to obtain a stable electron configuration. The atoms form chemical bonds to obtain stable electron configurations. So when atoms chemically bond, the resulting structure is a molecule. We talked about that. By the way, there's one thing we talked about last week that I need you guys to reiterate for me. What's the difference between a polar, covalent, and a... Don't just say covalent bond, because there's 2 types of covalent bonds. What are they? Polar covalent bond and a non-polar covalent bond. What does that mean to have a polar covalent bond and a non-polar covalent bond? I have told you already that whenever you want to know the difference between 2 things, you also have to do what? First, if you want to tell the difference between 2 things, you must begin with what? The similarity. So polar covalent and non-polar covalent. What is the similarity.
Polar.
One. Oh, the electron.
Both of them are sharing. So whether you're talking about polar covalent or non-polar covalent, both of them are sharing. It's not like one is giving electron to the other. Now that's ionic. Excellent. So what is unequal? What do you mean? Both are sharing, both are buying a house or buying a car. Exactly. So the electrons that are being shared, they spend more time with one than the other. So for example, you share a car. You put 10,000, your friend put 10,000, you bought a car for 20,000, and you're supposed to use it one day me, one day you. Your friend will now say, I'll use it for 3 days, you use it for one day. So the car is shared, but it's shared with more with one over the other. Same thing with water and in oxygen and hydrogen. Hydrogen is putting up. So you tell me which one you think is that. If one spend more with on one side, they are not equal. So you're not sharing the car one day each. You're sharing it 7 day one day the other one. So what do you think? Is that non-polar or polar? Polar means is when you polarize. So the baby polarized to the mom more than the dad. If you polarize, you tilt to one side than the other. So that's why we call it polar covalent, because oxygen is so big, the electrons are polarized more to the oxygen. But when you have carbon and oxygen, now that's is a non-polar. It's equal because carbon is as big as oxygen. But hydrogen is so small and oxygen is so big. You gotta know that one.
So basically, you can just know that polar covalent is shared unequally, covalent is shared equally.
Right.
No, wait, polar covalent is shared unequally.
Yeah.
Non-covalent is equal.
Yeah. Okay. So when atoms chemically bond, the resulting structure is a molecule, and the water molecule consists of two hydrogen atoms and one oxygen atom bonded together. So atoms bond by donating and accepting or sharing electrons to fulfill their octet, rule. So chemical reactions. So chemical reactions occur when atoms bond to form molecules or when bonds break. The substances at the start are known as reactants, and substances at the end are known as products. The arrow shows the general direction of the reaction. So the arrow is always pointing from reactants to products. Flour and milk and egg will point to pancake, for example. So the reactants come together to give you a product. So reactions must have balanced chemical equations where each element's number of atoms is the same on each side of the equation. So the law of the conservation of matter states that no matter can be created or destroyed. So there are two types of chemical reactions that are shown here. In some chemical reactions, reactants are joined to form a product. In other chemical reactions, they split to form smaller products. So here on the first one, you see where my mouse is pointing? A plus B will give you AB. So now they are joined together. But this is known as a composition. So you compose, you bring them together. Flour, milk, egg, they come together to give you a pancake. But in another reaction, you have pancake that you chop up and then that's a bad example. If you have salad, then you separate tomato and lettuce. And so now you began with salad, but now in the end, you separated them. The cucumber on one side and the olive on the other side and tomatoes and all the good stuff. Cucumber is good when it's pickled. No, it's not. Okay. It's good when it's not pickled. Are carrots good when they are boiled or steamed?
It depends. Yes, it depends. What it goes with. Depends on.
Okay, so the degradation, now let's look at hydrogen peroxide. Hydrogen peroxide looks like that. And hydrogen peroxide is not good in the body. That's the reactive oxidative species. So we have enzymes that detoxify. You know, they say antioxidant, like carrot. You know, I don't never like carrot, but after I learned that carrot has the carotene, ever heard of beta carotene? Raise your hand if you heard of beta carotene. So beta carotene is one of the best antioxidant. You know castor oil? Oh, that's the number one. You know, if you put castor oil on your face, you put castor oil, the woman, she has breast cancer, so she put castor oil in the bra and she left it there, the breast cancer was cured. Yeah, yeah. Put castor oil in your breast. Yeah, it's gonna remove it. If you have a surgery and there is fiber, you know when they do the surgery, there's scar tissue. Put castor oil there. It's gonna take it right off. If you have something on your face, pimples, whatever. What?
It goes in here.
I got some Haitian friends. Oh, you Haitian? Yeah, they just told me like last week, it was like, you Musketeers, Black Castor. I'm like, no way, bro. I've been putting that in my head.
Three Musketeers?
No. She's Haitian, maybe she could say better. I'm Jamaican, so I don't know. We Musketeers. We Musketeers.
We Musk 18?
We Musketeers.
We Musketeer. What is that?
Castor oil.
That's castor oil, yeah. And you put it on your face, on the hair. That's the best product. It's so now you will see that these antioxidants, these are enzymes that will make these very dangerous hyperoxide reactive oxidative species. It will break them down into what? Look, it brought them down into useful water, so we recycle them. Recycle hydrogen peroxide into water and oxygen. Compounds. Compounds contain atoms of multiple elements. Homonuclear molecules that contain atoms from one element. Irreversible reactions proceed in one direction until reactants are consumed. Reversible reactions can go in both directions and are denoted by a double-headed arrow. So double-headed arrow meaning it could go either way. So the reaction can go to completion or it can return back. Irreversible reaction can only go in one direction. You cannot go back. Like the bad example I gave. Once you become pancake, you can never go back to being flour. But once you become salad, you can go back to being tomato. So some of the reactions are reversible, but some of them, once you cross that line, you can never come back.
So you said a reversible reaction can never go back.
Reversible, it can. That's why they call it reversible, because you can reverse it.
So wait, which one you said can't go back?
Irreversible. Irreversible, can never go back. At equilibrium, forward and reverse rates are equal. So that's equilibrium. That is very important. What is equilibrium? Equilibrium is when the forward and the reverse reaction rates are equal. So example, in human blood, excessive hydrogen ions bind to bicarbonate ions, forming carbonic acid, which can be converted to carbon dioxide and water. So ions form when atoms gain or lose the electrons to become more energetically stable. So cations are positively charged ion. We did all of that. I say it again, I feel bad. Okay, so you're gonna go home, read that. You're gonna go home and review that, the covalent bonds and other interactions. So covalent bonds involve sharing electron pairs between atoms to satisfy the octet rule. Polar covalent bond. Did we talk about that?
Right.
So we talked about the polar covalent bonds, non-polar. Okay. Non-polar, we talked about non-polar. Non-polar is when they are equal, like carbon and oxygen. Okay. Van der Waals are a type of weak interactions, as we will see later. They are used in protein folding. So proteins come out of the ribosome in like linear beads. Are you guys taking AMP1, Anatomy and Physiology
Yeah.
1?
You the teacher?
No, because you guys are going to be learning that. You're going to be learning the proteins. So so you're taking now AMP1
Next semester.
next semester. So you're not taking it concurrently with this class.
No.
I see. So Van der Waal interactions, you're going to learn in AMP1 that these are the type of folding. So you need hydrophobic effect. We need Van der Waals interactions to help fold this nascent mRNA transcript that comes out of the ribosome, this nascent polypeptide, not mRNA transcript, the polypeptide. We fold it properly in order to get in order to get this proper folding, and then we move from 1 dimension into 2 dimension, 3 dimension, and 4 dimensions, like something like hemoglobin. Now that's a globular structure. So you will see this folding is made possible with these interactions, these van der Waals interactions. So that's the summary. Okay. All right, listen, we covered everything.